let's come back onto campus.
Okay.
You get here in 1977. Don Knuth is clearly important to you. David Patterson.
David Patterson.
He's at Berkeley?
He's at Berkeley. We had not yet started on our project. I actually began working on some ideas in programming languages and parallel programming. And then what happened was DARPA, the Defense Advanced Research Projects Agency, started funding a program they called the VLSI program, Very Large Scale Integration Program, and this was based on work that Carver Mead and Lynn Conway had done together, and they'd written a textbook. Lynn was at Xerox. Carver Mead was down at Caltech, basically saying this integrated circuit technology is a fundamental technology. It should be available not just to people who are electronics engineers and circuit designers, but people who can think about system uses of this technology. So it was very insightful because they were projecting what Moore's Law would do. So Forrest Baskett, who became one of my mentors, had come back to Stanford after taking a sabbatical at Cray or at Los Alamos actually, and had enticed DARPA to give us a research project. And he had recruited Jim Clark to Stanford. Jim and I shared an office and an administrative support person. And Jim came with a real vision, which is we could use this VLSI technology to dramatically enhance the ability to do three-dimensional graphics, which at that time, these three-dimensional graphics workstations were $100,000 to $200,000 each. So Jim was going to provide more performance for less money by using this new technology. So we started working on that, and he had an interesting problem. There was a low level of programming, what we call microprogramming, that's inside the chip that then provides a set of commands that ordinary programmers would then use to do graphics transformations, like draw a triangle on the screen or draw a three-dimensional cube. And he needed a way to write this stuff. So I wrote a tool and a language that helped figure out how to write that microcode and then generate the silicon out of it. So it turned out that attracted a lot of attention. The field was just booming. The whole VLSI thing was taking off. And Jim decided to take the work he had done on the geometry engine and turn it into a company. And so he offered me a kind of consulting role at the company. I did that. That was my first experience in entrepreneurism. I had also worked a little bit on another startup company called Silicon Compilers that was a spin-out out of Caltech. And the name refers to the fact that they were building software to help people design chips. Well, that's what my research work had been. So I spent a little time with them and then spent more time with Silicon Graphics. And that was my exposure to understanding something about the entrepreneurial process. I was there one day a week, so it wasn't a lot, but I got some understanding of it. And that was my first entrepreneurial.
But do I understand you correctly that you were involved even at that early stage, not just with the technical aspects of the business, the Silicon Graphics, wherever, but with the business plan? Not
really. I mean, at that point, I was a part-timer. I was intimate in at least the technical decisions about where it was going. So I'd say on the technical side, what are we doing? What are we building? How are we thinking about it? But not on thinking about what would the business plan be like and things like that.
So the company that you then found is MIPS, correct?
Yeah.
And you had co-founders?
Yes, I had co-founders. So what had happened, so after this geometry engine, the Silicon Graphics thing spun out, and so we started thinking about, let's start another project. We still had funding. They were interested in doing it. And we decided to work on a processor, on a CPU. And we decided that because I had also done some work on compiler technology, and the two went hand in hand. So we started a graduate programming course, a graduate brainstorming course, which came up with what are now called the principles behind reduced instruction set computing. There was a project working on similar ideas at IBM, and then the one at Berkeley as well, that provided Dave Patterson's project at Berkeley provided the name for it. So we started working on that. We discovered these dramatic results. I mean, dramatic. We were a lot faster than what commercially was available then from Intel or Motorola.
And this surprised you? Or?
I was surprised at how big the gap was.
Yeah.
I mean, there was serendipity. We knew, essentially we said, this is a new way to design computers using this technology. Computers, existing microprocessors were based on mini computers. Well, mini computers were designed using really old technology with a different set of trade-offs. So essentially we said, clean slate, start from scratch. In the process, with a lot of serendipity in the process, we discovered some key insights that turned out to be much better in this technology. So, you know, we could build a chip that could outperform a $200,000 mini computer. I mean, so that was a remarkable insight. So, you know, we start publishing our papers. We figure, you know, these are great ideas. I was very happy with my Silicon Graphics consulting role. It was very nice. We figured people would pick them up and run with them. No, that's not what happened. What happened, in fact, Forrest Basket had started a little research lab here in Palo Alto for Digital Equipment Corporation on the West Coast. Some of their people had worked on our project, and they were working on similar ideas. They tried to sell it back east with no success. They couldn't get them to pick up the ideas. We couldn't get anybody else interested in it. And finally, along comes Gordon Bell, who was a very influential computer scientist, had been involved in the early days of Digital Equipment Corporation. He says, you know, if you want this technology to see the light of day, you're going to have to start a company because it's not going to happen otherwise. It's too disruptive. It obsoletes too many of their existing products, and that's why they're so reluctant to do it. So I started thinking about this, and it turns out one of the people who would become a MIPS co-founder, John Masuris, is on sabbatical from IBM. He had worked on related technologies at IBM. He really believed in this RISC approach. And when IBM put their project on hold or cancels it, he said, I'm not going back there. And I said, well, you know, Gordon Bell's trying to get us to start this company. He says, that's what I want to do. So we went and got another colleague, Skip Stritter, who had been involved in the Motorola 68000 project. And we went to the venture capitalist with the world's most ridiculous business plan. I mean, David, this business plan, it's a piece of junk. It's a set of slides. Here's how much money we need. It was all about the technical part of it. Nothing, no market analysis, no anything else. I mean, it's an embarrassment when I think about it. But, and of course, that probably hurt us. We could have used more thought on those things. But the technology was so much better than what else was out there. That carried us through lots of other mistakes in how to set up and run a company.
Yeah. But there's something that doesn't square here with my understanding of the Valley's culture. That it's, in my view, it's hungry for all innovation and disruption, but you're saying that this was too disruptive and too innovative.
Well, it was too disruptive for the big companies. So, because we first tried to get, IBM and Digital Equipment both decided not to go ahead with it. So it was too disruptive for the main players. In fact, what subsequently happened is when we spun MIPS out and started building, its first customers were companies who needed to get a leg back up on those other companies. I think, there was a lot of people who didn't believe in the technology. I gave a talk once. Dave Patterson and I were both on a panel, and we had an antagonist who was on the other side. Basically, this stuff isn't going to work. All this. So one person says, this was just after the company got started, Hennessy just got $1 million from the venture capitalist to go build a company based on this. What should he do? He goes, take the money to go to South America. Right. So it turns out his project got canceled eventually at IBM and ours didn't. So but there was a lot of disbelief. And it's one of the things about being an entrepreneur. Everybody else sees the glass as half empty, particularly for an academic project, because an academic project is a prototype. It's not the real product. You don't have all the bells and whistles you'd need to ship it to a customer. But you have a good idea about how you're going to fill the rest of that glass.